right, welcome back to my channel, or if you're here for the first time, good to have you here. We're going to try something interesting. I've gotten into astrophotography as a hobby over the last few years, and it's been a lot of fun. Really challenging hobby, kind of expensive, as you might imagine, but it's gotten me interested in doing some astronomy. And being an engineer, I always have interest in making things, trying things, tinkering with stuff, fixing or changing stuff. In this case, getting into astrophotography, I had decided that, well, astronomy is an interesting thing, but I don't really have a way to observe while I'm imaging. My main imaging rig is going to be running like all night long, and if it's a clear night, I'm taking pictures. I don't have another setup in order for me to sit there next to my imaging rig and observe stuff, just look at things using an eyepiece. So what I'd like to do is get another telescope, but being me, I can't leave well enough alone, and instead of just buying another telescope that I can use to observe, I thought it might be interesting to build a telescope. And not just build a telescope, but to build the entire telescope for the most part. There's a few parts that I'm going to end up having to buy, but overall, making a telescope. So we'll see how this goes. It's going to be kind of a long project made up of like multiple different mini projects, if you will. And the first project, the first part or mini project of this entire telescope idea is going to be to make a telescope mirror. Rather than buying one, which would be the easy route, I decided to try to make one. Make a telescope mirror from scratch, by hand. So I have everything set up here to start that journey, and I figured it'd be interesting to document that process of trying to make a telescope mirror for the very first time. People like me who have no idea what to do when they first start looking into this, it's hard to find a lot of good information on it. It's getting better. There's people who have started making videos or have had videos, but it's still kind of hard to wrap your head around some of the different concepts involved in making a telescope mirror unless you have a mentor, someone who is knowledgeable and experienced that can help you and guide you along the way. And I don't have that. I have the internet. I browse around on forums like Cloudy Nights or Stargazer's Lounge. And there's a lot of good posts and stuff in there about how to make mirrors or how to fix issues that have maybe been ground into the mirrors incorrectly. But it's still hard. It's still hard to find a lot of good information. So I figured it would be worthwhile for me to try and document my process as I go. Maybe not every single little step, but at least kind of show my journey, my experience as I go through and make this whole thing. So I'm going to make a telescope mirror, right? So what's involved in making a telescope mirror? Well, the first thing is you need to have material to make a mirror, and that would be a piece of glass, like this one. I've got a nice piece of glass. This one I bought specifically as a blank for making a telescope mirror. Now, sometimes you can buy telescope mirror blanks that are already, we'll call them 80% of the way there, right? They're going to be pre-ground so that they already have a spherical shape in them, and then you have to finish them and polish them and then send them out for coating. This particular one was bought as part of a kit. I've got the kit here on my table. This particular kit was purchased from First Hand Discovery. Really nice little website specifically around telescope making and mirror making. And that kit has pretty much everything I needed for the most part, and obviously I had to make a few other things or set up a few other things, but that kit came with this telescope mirror blank. So this is a 6-inch diameter mirror blank, so that's the size I'm going to be making, 6 inches. I've been reading a lot, and that was usually the size that was suggested for someone's first mirror. It's smaller, so it's a little bit easier, simply because there's just not as much work involved in grinding the shape of the mirror as you would have in, say, a larger 10 or 12 or even bigger diameter telescope mirror. It's also cheaper, so going with a smaller piece of glass, you obviously have less glass, but you have less other things involved, less grit and other stuff that you need to buy, so the kits are just cheaper. So, step one, piece of glass. Now, the glass that usually comes with these kits, I don't think it's your typical just plate glass. I think these are actually low expansion glass mirror blanks, but there's a lot of folks making mirrors using simple plate glass. You would have to find a supplier for plate glass. As you can see, this is pretty thick. This is a 1-inch thick blank, and that's usually about as small as you really want to go. My understanding is typically the diameter to thickness, you usually want about a 6-to-1 ratio. So if you had a 12-inch diameter mirror, you would have a 2-inch diameter thickness, and that's considered full thickness. There are people who are making thinner mirrors at this point, but that's going to go beyond my experience or knowledge that I've even really started delving into at this point, and it's not something that I want to worry about, because when you have thinner mirrors, there's the chance that you could flex the mirror simply by grinding it, and you might end up figuring it incorrectly. So anyway, full thickness blank. Along with that, the kit includes a bunch of dental plaster, and that's used to make your main grinding tool. Doing a bunch of reading, it sounds like in, we'll say, ye olden days of mirror making, which isn't really that long ago, but most of the time what people would do is they would use 2 pieces of glass. And using 2 pieces of glass, they would put one piece on top of the other with some grit in between, and simply by applying pressure, that will gradually end up making one piece become concave and the other piece will become convex. And then gradually they continue to fit nicely against each other, and they'll both become spherical together. Just one will be concave and one will be convex. However, the downside to doing that is you basically waste a piece of glass. Not really waste it per se, but you use a piece of glass to grind another piece of glass. So rather than having 2 mirrors, you end up basically sacrificing one piece as a grinding tool. So instead, what most kits and what most mirror makers are doing nowadays is they're making a separate grinding tool. And so I've already made mine. This one's made out of, again, dental plaster. There's another product out there called dental stone, which I believe is more desirable. It's really resistant to moisture, but it does cost a little bit more. So this kit came with dental plaster, and because it's plaster and not dental stone, it's not got the same epoxy in it, and because of that I ended up sealing it. So to make this, you basically you make a little dam using some plastic or cardboard around your mirror, and then you pour mixed dental plaster on top of your mirror, usually with a piece of saran wrap or something in between, plastic wrap, just so you can separate the two. And you pour that, you let it harden and cure, and then once it's ready, you can go ahead and attach ceramic tiles on top of it, which I have here. You can kind of see those. However, in my case, being inexperienced as I am, apparently I left a little bit too much space in between these tiles. You want these a little closer together, and so instead of laying them out in a nice little pattern, I figured random would be a little better, but unfortunately, again, a little bit of some bigger space in between some of these tiles. And so the suggestion was given to me on one of my forum posts that I should really reduce the amount of area in between here. And I did that by pouring some 2-part casting resin in between the tiles just to kind of fill it in and make those gaps a little bit shallower. So we'll see how that works. Hopefully that does the trick. But anyway, this is my grinding tool. Depending on what you're doing, the grinding tool can be either underneath the mirror and you're grinding with the mirror on top, or in later stages you might flip that over and then have the mirror on the bottom with the grinding tool on top of it. So we'll see how that goes. I also have a little piece of bubble wrap that I've gotten for underneath the tool or the mirror just to give it a little bit of cushion. Now as I'm going, I'm going to need grit. So the kit came with a bunch of grit. As part of this, I have another thing of dental plaster. This is to make the polishing tool later on. So I'm going to have to make another one of these to polish the mirror to its final stage before it gets coated. But we also have a bunch of grits. And I'm going to start with some really coarse stuff. We've got 80 grit silicon carbide. This is going to be my starting grit. So I'm going to set that out here. But if I grab my kit here, hopefully you can kind of see that. There's a bunch more in here, a bunch more grits, and they're all in decreasing size. So as we get finer and finer, we're going to get a smoother and smoother mirror finish. And it goes all the way down to when you get to the polishing stages. You go all the way down to 5 micron white aluminum oxide, and then eventually you go to cerium oxide, which I believe First-Hand Discovery labels theirs is somewhere around like 2 or 3 micron polishing grit. So extremely fine. Now along with that, as I'm going, I've got a couple of bins here to wash my grit off the mirror as I'm going, or off of the tool. And that's just to kind of get rid of the stuff that's been ground off, the glass or the ceramic that's kind of been ground off and kind of turn into a bit of a mud. And that mud will build up over time and make the grinding process a little bit less efficient. So as part of this process, every so often, which they call a wet, so once the grit begins to dry out a bit and it's broken down and you kind of need to replace it and refresh with some new grit, you'll usually rinse it off. And I've got 2 bins, so I can rinse it off kind of coarsely and then really clean it up in the second bin. And then I'll bring it back over into my grinding station here. And then apply some new grit and then continue on. So each time that grit begins to dry out, and after it's broken down or it's gotten a little too thick and muddy and I want to clean it off and get some fresh stuff, that process is called a wet. And that can be anywhere from maybe a couple of minutes to 4, 5, 6 minutes. Depends on how much water you have and how far the grit is broken down. So we'll see. We'll see how long that takes. To measure the grinding process, I've got some tools here. I've got my granite plate. This is just so I can zero my measuring tools. But the simplest way that you can measure, as you're going and you're grinding your concave shape into the mirror blank here, what a lot of folks will do is they'll just use a straight edge. And they'll put that straight edge across here and then use some sort of known thickness object to measure the depth that's been ground out underneath this. So there'll be a little gap underneath the bottom of the straight edge. And you could use, I've heard people suggest drill bits. You would need drill bits or drill bit blanks. That didn't really excite me because, well, you don't really have as much adjustment when it's just drill bits. You'd have to get a bunch of different sizes, and I just didn't want to have to deal with them rolling around. So instead of using drill bit blanks or drill bits, instead you could use a set of feeler gauges. So you can buy a set of feeler gauges, and it's got all these little blades in here, and they're all different thicknesses. Each one has a label on it about how thick they are, and you can use these to figure out how much depth you've ground out in the center. And that's great. So another way that people measure stuff. The way that I decided, being an engineer, and I can't leave well enough alone, I wanted to get a little bit, I don't know, more efficient, not necessarily precise, but more efficient with that measuring process. And so I ended up 3D printing what's called a spherometer. And a spherometer is this little guy. It's basically just a 3-pointed gauge, a little depth indicator. So I've got my depth dial indicator in the middle. And I just use these 3 steel ball bearings, and that's what actually rests on whatever surface I want to measure. And in this case, it's going to measure based on the very edges here. So I would set this on here, and then I can measure the depth in the center. And this one is exactly 6 inches, well, pretty much exactly 6 inches, within maybe a few thousandths of an inch diameter. So if we were to draw a circle between my 3 ball bearings and the place that it touches in the center, it's about 6 inches. If I want to check for local spots that might be a little higher, a little bit lower, I can use a smaller one. So I printed a 3-inch diameter one. Again, has 3 little ball bearings, and I would just pull the gauge out of this one and press it into this one, and then I can move it around on my mirror blank and kind of check and see how consistent my grind is. And so it's going to check just a very localized section of this. So again, not really necessary, but I just apparently couldn't help myself, and so I'm going to use these. And I might even check those against the feeler gauges just to see how close they are. Again, doesn't need to be super accurate during the rough grinding stages. And once you get to the later stages, especially when you get into polishing, these tools are not sufficient to even measure the curvature. Once you get towards polishing and you want to take your mirror from a spherical shape to a parabolic shape, it's such a fine change in the mirror. We're talking potentially millions of an inch difference between a spherical surface and a paraboloid, and these are not going to cut it. So these are really only for fine or for the rough grinding stages, just to make sure that I'm kind of getting everything going in the right direction. So again, the granite plate is just to zero everything out. It's flat to within, I believe, like a couple 10,000ths of an inch, and then that's all I need this for. So I'm going to move this out of the way. Okay. And I just got an old towel. I just put it under the granite plate just so that it doesn't scratch anything. So this is going to be my grinding station. So I've put this together. I got a free barrel. The barrel was actually just being left on the side of the road by a neighbor. It's a clean, well, pretty clean barrel. It was used to hold some sort of fruit juice. You know, I rinsed it out, and just to make sure that it's fairly clean, it has the clamp band on it, it's got a lid. And in order to make this little grinding station, I want to make sure I'm holding whichever item, the mirror or the tool, is on the bottom. And so to do that, I just screwed 3 cleats onto here. So I kind of measured the size of my mirror, so the mirror fits right in there. And then these cleats just touch 3 spots to hold the mirror in place. And there's a tiny, tiny bit of wiggle room here. And the same thing should be true for the tool, because when I made the tool, the grinding tool, I made a dam around here using the size of the mirror blank. And so this should fit nicely right on top of here. Okay. So it should be almost exactly the same size. It's a tiny bit different just because, you know, the material I use for the dam around here is a little bit flexible, but this does fit. I did mark it so that I know exactly how it lines up so that it fits, but I can put that tool in there and then I can go ahead and move the mirror on top of it. And the same thing vice versa. Again, I just have a little piece of bubble wrap and that's going to go underneath it just to give a little bit of cushion. And then lastly, at this point, I seal it. I did go ahead and seal it. I used a clear coat on top of this to waterproof it. In my case, I used some General Finishes Armor Seal because that's just what I have. You might have another clear polyurethane coating and that's totally fine, but I clear coated 3 times. I put 3 coats on the main base here as well as all of the cleats. I pulled the cleats off and then clear coated them separately so I can remove them if I want to, that they're not, the clear coat doesn't like bond them onto the top. But even though I've waterproofed this, I don't want grit to get in anywhere. One of the major problems you can have that I keep reading about is grit can hang around. You can have grit get stuck in so many different places, little nooks and crannies everywhere. Grit can get stuck in little nooks and crannies on the tool. Grit can get stuck against the little corners of the cleats or in these little screw holes of the cleats. It can get somehow wedged underneath these cleats. It can get around the outside here. And sometimes it could even get slightly embedded into this wood top. And the last thing I want to do is have a larger piece of grit than what I'm trying to polish or grind. You have a leftover piece of grit from the previous stage that's larger, somehow get loose, get on top of your tool or on your mirror, and suddenly now you're scratching deeper scratches into your mirror than the size grit that you're trying to work on. It's kind of like taking finer and finer sandpaper and then you accidentally scratch it by having a little granule from a larger piece of sandpaper. And so that would mean I'd have to back up and basically re-grind that larger step again to smooth it back out and then work my way back down. So if I had to do 2 or 3 or 4 steps backwards, that would take so much extra time. My understanding is that by the time I'm done with this process of grinding through all the different grits, all of the polishing, and then I can send it out for coating, my understanding is that by the time I'm done with all of that, typically it's going to be somewhere around 80 hours worth of manual work. So the last thing I want to do is screw that up somewhere, scratch the mirror, have to back up and redo a whole bunch of these steps. Not only would it take me a whole bunch of extra time, I might even have to buy some extra grit depending on how bad it is. So anyway, I want to make sure I protect my mirror, I want to protect my workstation, and I want to make sure that I don't really get I get as little grit caught anywhere as I can. And so to help me with that, I'm just going to move this out of the way for just a moment. To help me with that, I had a suggestion by a forum member that I can just take some sheet plastic, like a garbage bag. In this case, this is a really large garbage bag. I think it's a 50 or 60 gallon garbage bag. But basically, just drape that over, right? And that's just going to act as essentially a drop cloth for this process. I might eventually wear some holes in this around where the cleats are going to touch the tool or the mirror, but this should hopefully keep the grit contained. So that's something I want to do here. So in addition to the waterproofing, I'm going to put this plastic sheeting down just to try and keep the grit contained down here. And then I can either take it upstairs and rinse it off, because obviously I'm in my basement, But I can take it upstairs and rinse it off. If it just gets too gritty, or if I want to switch to a smaller grit, I can flip it over, or I could turn it inside out, or even just get a completely new piece of garbage bag, and that way I don't have to worry about any of that older, larger grit kind of getting mixed in. Other supplies that I have with me, I've got some of these little water bottles. These are like your, I guess, laboratory or medical type of water bottles where you can fill it up, and then when you squeeze it, it sprays out. And so that'll make it easy to irrigate certain areas, either to wash some of that gritty stuff off or to apply some polish mixed in some water as a slurry. So I can use that to apply some stuff. And I've got a couple little bottles, a little bigger one, a little smaller one, that I can use to help me. You could also use just a series of little squeeze bottles. I got some of these just in case I do want to use more of these. We'll see. I've got excuse me. I've got some extra bins just in case I want to store anything, or if I want extra water bins, or one of them gets damaged or whatever. Yeah. Other than that, there's not a whole lot else along with these kits. There's also some pitch. This is the very last stages of the mirror making process. Pitch, if you're not familiar or haven't heard the term pitch before, pitch is basically usually made from pine resin, and it can be in I guess, I don't want to call it purities, but it can be in different types or different stages of processing, and that will determine how hard or how soft this pitch is. But essentially what this does is it allows you to polish your mirror by creating a perfect fit against the mirror. So when I get to the last stages, I said I had some more Dino-Blaster here. I'm going to make another one of these tools and then pour some softened pitch on top of here. So you heat it up, you soften it up so you can pour it on top, and then you can press your mirror against that pitch to get a perfect replica of that shape. And then you put some of that last super fine cerium oxide polish on there. It kind of embeds itself in that pitch, and it becomes a polishing tool. The nice thing about pitch, though, is that as you're polishing, pitch still flows. Even though it looks solid, you can't see it right now, but it comes in essentially like this tin. I have to break it up into chunks and then I can melt it. But basically this stuff still flows. It's really slow, but it doesn't actually harden at room temperature. It's still hard, but it can flow a tiny bit. And so as you're polishing and the surface continues to wear down just a little bit, it will continue to form itself perfectly against the shape as you are polishing. So anyway, we'll get into more detail about this stuff later on when I get to that stage. I'm going to have more videos between now and this point, but at least want to explain what this stuff is and kind of sort of how it works. The last thing that comes with all these is these kits include instructions. So I've gotten two different kits. One's for a larger mirror that I want to do later, but they all come with instructions so that you can follow their instructions on how to create these tools, how to begin the process of grinding your mirror and figuring the mirror into something that will eventually be usable in a telescope. So anyway, yeah, I have no idea how this is going to go. It's going to certainly be an adventure. I hope that my mirror turns out good enough that it will make a really nice little 6-inch telescope, but we'll see how it goes. I'll make some more videos as I'm going along, probably to explain maybe some of the different steps in a little more detail, maybe about how some of the specific methods of moving the tool in certain ways or positioning it in a certain spot affects the grind, or to talk a little bit about things as I'm just progressing and where I'm at. But yeah, stay tuned. I'll make some more videos and keep you guys updated on how this thing goes. We'll see. But like I said, hopefully at the end we'll be able to make a telescope. So thanks for watching, and we'll see you in the next one.